A to A is
Yeah, non A1A and A2A.
yes.
Yeah, what?
From today, we beat frequency or something.
Hmm. BFO we already discussed, no? It is a button same as ident.
Okay.
Okay. We'll just briefly go through how this ADF works because this loops and all that, aerials, they won't ask you any question nor it is needed for you. But they have still given it in the books for you to understand how it works. It's mainly for the understanding purposes. Okay. So I'll give you a brief idea about it and then we'll continue with the errors and other stuff. Basically, the ADF antenna on an aircraft looks like this. You can see multiple images. It is like this thing. Okay, it will have a loop aerial and sense aerial on it. It will be on the top or bottom of the aircraft.
Okay.
It will be fixed somewhere there, the flat thing. Okay, see in that it will have a loop antennas and sense antennas surrounding it, and it will have electrical connection and all that. Okay, that's how it basically looks, just for your idea. Now, to understand the basic working, so whenever the electromagnetic wave of this NDB, it will be traveling through, it will travel in this direction. Okay, usually vertical, right? So it will be traveling in this direction.
Yes.
So depending on the difference in phase at loop A and loop B,
Yes.
it will figure out the signals, phase difference. It will figure out the bearings. Okay, but the problem is if so, this is now let's say the wave is coming from here and it is almost in the same path, right? Now, if the wave is coming and this thing is like this, like it has come out, imagine it is perpendicular to the wave. In those cases, what happens? Both the loops will get same current.
Mm-hmm.
Then phase difference will be zero. It won't be able to give you any reading. So this problem occurs at 2 points, right? One, when it rotates from perpendicular to 190-degree, then again it will go reverse. Now B will come this side, A will come this side, again completely 180-degree phase difference, and then again it will rotate back, and again A will be on this side, B will be on this side, kind of like that, rotating thing. Okay, so at 2 points it will become zero. So to avoid that, we have a loop aerial. Now this loop aerial will, along with the sense aerial, for to avoid that we have sense aerial. This is loop aerial. Along that we'll have the sense aerial around it. These two will work together, and then it will be able to give you a direction in one particular distance. Even though there is phase difference at 2 points, this sense aerial will help in overcoming that disadvantage. This is the basic phenomenon. You just need to understand. You don't have to worry much about it. No questions on it, but that's how it works. Okay, this readings will go through electrical means to your ADF and give you the display. It will display in the ADF bearing. Okay, this is how basically ADF works. Okay, so we have to discuss about types of bearings. So bearing, when you say bearing, it is the direction from the true or magnetic north to whichever point, either the aircraft or the station you are taking. Now, let's say This is the station of NDB. True north, and let's say this is magnetic north, and this is the aircraft. Your true bearing from the station will be whatever the position of the aircraft is, you take the angle from true north, that will be your true bearing.
Okay.
So true bearing, let's say here it is 090. So true bearing of aircraft from the station is 090. Then if you take magnetic, it will be 090 plus whatever this addition, let's say 20 degree. It will be 110 degree will be your magnetic
Okay.
bearing. That's how you figure out the bearings. Now relative bearing. Relative bearing will be from the nose of aircraft clockwise to the station. Now whatever the direction of the nose is. Now let's say like this. It is on heading 070, let's say. And this is at 270, let's say. Okay. 270 degrees. What will be the relative bearing?
200.
Yeah.
100.
From the nose of the aircraft to the station is this 70 minus this 270 will be 200 degrees will be your relative bearing. Doubts? Not understood?
No, sir, it shouldn't be 200, right? It should be more.
How?
Like the station is at 270. 270 Okay, 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 got it.
Aircraft is on 090, but it is the heading 090. No.
No.
Aircraft heading is 070 degrees.
Okay.
This would have been 090 degrees.
Okay.
It is on 090, but its heading is 070.
Okay.
Now, what will be the relative bearing? Whatever from this nose to the station it is.
Okay.
What is it? Okay, this is 180. From here to here is 180.
180.
Plus this 20,
Got it. 200.
200 degrees will be your relative bearing. Relative bearing is always from the heading of your aircraft to whatever station or whatever place you are taking. That will be your relative bearing. Okay, understood true bearing, not magnetic bearing and relative bearing. Don't get confused in this. Okay. Now, what are the factors that are affecting the range of NDB? Obviously, the range is affected by a lot of other things because radio waves will be affected by the disturbances. Okay, the first one is transmission power. Where I already previously mentioned, higher the power, higher the range. Okay, so the factors affecting NDB ranges are transmission power. Higher the power, higher will be the range.
So what is that? TX transmission.
TX is transmission, RX is receiving.
Okay.
Receiver. Those are the shortcuts we use in aviation. And even in the radio, when we are transmitting, TX will be written on the radio display. Whenever you are receiving a call, it will read RX. It will display. It shows that you are transmitting and you are receiving to show that. Okay, but this range is proportional to square root of transmission power. It is proportional to square root of transmission power. So if you want to increase the range by 2 times, you'll have to increase the power by,
Two times.
it's not directly proportional. I mean, it's directly proportional but not directly to the
Root.
square root. Yeah.
Root. Nothing is by root. If you want to increase root 2 into power.
If you want to increase this by 2, if you increase, what is the, you,
Okay.
what is it?
Increase it by root 4.
You will have to increase it by root 4. The root 4 is 2.
No.
So if you want to increase the range by 2 times, you'll have to increase the power by 4 times. Understand that. If you have to increase the range by 4 times, you'll have to increase the power by 16 times. Got it? So higher the power, higher the range, but it is directly proportional to square root of power. The range is directly proportional to square root of power. Clear everyone? Second is terrain. What happens if there is terrain?
Disturbance of gradient. You get the waves will get dropped.
It will get, they'll become less powerful. Okay, if there is terrain, the range reduces, especially on land, on sea, range will be higher. Over land, range will be lower. A lot of disturbances on land. Okay, and the medium. The friction now between the ground and waves will be more than the friction between sea and water and waves. Okay. Third, frequency or transmission frequency. This I had mentioned in radio theory. Higher the frequency, lower the range, or lower the frequency, higher the range. Indirectly proportional. So frequency is indirectly proportional to range, or range is indirectly proportional to frequency. Okay, got it? Night effect. It's very important you remember the effects. They'll ask you a question on this. So, in night effect, what happens? Range increases or decreases at night?
Decreases.
The range decreases at night.
Because E and DF layer will be less electrolyzed. E and D layers will be less electrolyzed.
Night effect, good. At night, the range reduces up to max 70 nautical miles. Okay, at night the range reduces up to 70 nautical miles.
Like nautical miles like radius or height?
Okay. Height,
To max.
the radius.
Okay. From the transmitting
70 nautical mile height ಎಷ್ಟಾಗುತ್ತೆ? One nautical mile is how many feet?
1.8 to
Feet.
6080.
One nautical is 6080 feet. Now imagine 70 nautical mile. Will you fly that high? 10 nautical miles, let's say 60,800 feet. Will you fly that high? No.
From transmitting stations, max 70 nautical
Like
miles.
whatever the range in the daytime was, in the night it will reduce 70 nautical miles of the daytime range.
Okay, 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 got it.
If the range in the morning was 200 nautical mile, in evening it will be up somewhere 130, 140 nautical mile
Got it.
at night. Okay.
Captain, why does it reduce exactly?
In the night, this one, what do you call the night? The ionization layer will go higher, right?
Yeah.
Yeah, because of that, the wave will have to travel more higher and come back. So at the end, overall range will reduce because now it will either give it more power, or if you want to keep work with the same power, then the range will reduce to travel more distance. Got it?
Yeah.
We'll discuss actually this affects. Wait 1 second. Okay, when we discuss, we'll discuss in depth why and how. Actually, there is also disturbance from other frequencies at night. That's why. Okay. Uh, Fine. Next is accuracies. Accuracies in the daytime. Accuracies in the daytime will be up to 70 nautical miles. Accuracy will be only plus or minus 2 degrees. Accuracy in the daytime of NDB up to 70 nautical miles. Accuracy will be only plus or minus 2 degrees. That's all. Like error will be only plus or minus 2 degrees. And beyond, accuracy will be plus or minus 5 degrees
Okay.
beyond 70 nautical mile. This is within DOC, where DOC stands for designated operational coverage.
Okay.
Whatever is the designated coverage of that NDB, up to 70 nautical mile, it will be accurate to plus or minus 2 degrees. Beyond that, within the designated operational coverage range, it will be accurate only to plus or minus 5 degrees. If you go beyond that, error is very high, accuracy is low. Okay, types of NDBs we already went through. Locator NDBs in ILS marking systems, then en route, long range NDBs, all that. Okay. Now, factors affecting accuracy of EDF, in that first, night effect. During night, due to lesser electron density, skywave is present in medium frequency band also. This skywave interferes with the horizontal arm of loop, causing distortion of the melt position. Relative bearing indicator pointer oscillates. There is a loss of signal and forwarding. This error is called night effect. So what is happening in the night is because of the ionization factor, these sky waves which we are traveling will come down to medium frequency range. Okay, these now ADF works in LF and MF. This the skywaves will now start disturbing this ADF signals. Hence, because of that, the accuracy will reduce. Got it?
So can you explain it? What I
The ADF works in LF and MF bands. Correct, at night, because of the night effect that the layer of ionization will go higher, the frequency of the MF, these sky waves will come down to MF bands. Now these MF bands, now ADF is also working in MF band and these sky waves are also in MF band. What happens, there will be disturbance between those two. Now ADF will be receiving those sky waves also, so it will get error. Okay, and it will start to oscillate as per those signals also, that aircraft in the ADF. That's why there is a loss of signal and fording. This error is called night effect. Clear, everyone?
So it is not accurate during the
Yeah, it is accurate only to certain distance. If you go beyond that, because of the loose like weak signal of ADF and the sky waves interpreting, the error will be lot. If you are very close, within the proper range you are close, then the error won't be that much, it will be accurate. The farther away you are, more the error, right? Because if you go beyond 70 nautical mile, error is already 5 degrees. Now further different disturbance in that, it will lead to much further error. Okay, method to reduce night effect: use the beacon which is transmitting at low frequency, because lower the frequency, more is the ionospheric attenuation. Presence of sky wave will be less. Night effect is maximum at dawn and dusk. Now if you are using low frequency, the sky waves which are on medium frequency will not be able to disturb you much. Okay, hence at night use the beacon on low frequency, and the presence of sky waves will be less in the lower frequency, and the night effect is will be less, but night effect will be more maximum at dawn and dusk, at sunrise and sunsets. That is dawn and dusk, right? Use the NDB which is within 70 nautical mile from the aircraft position, as first skywave return is received at a skip distance of 70 nautical mile or more. Use the NDB. If you're using NDB station, use the closest one within 70 nautical mile, because NDB usually works on direct wave, right, line of sight. So use whichever is in 70 nautical mile or less, because once beyond 70 nautical mile, the skywave will hit and reflect back. That skip distance will be 70 nautical miles on an average. Okay, so you will have more accurate NDB readings. Use a beacon which is transmitting at high transmission power, as ground wave will be stronger. Okay, so whatever transmission power is being affected, was affecting the range, you use high power at night, so that you can send stronger signals to a larger distances. Got it? This is basically the night effect of NDB. How errors increase and how you'll have to correct for it at night. Okay. Second, coastal error. Are you writing down? These effects are very important. They'll ask you question. These effects will study for every instrument, NDB, VOR, whatever we go through. Okay, and they will ask you a question on this, like what happens in night effect, increase, decrease, all those things. There will be questions on it. Clear with the night effect? Next is coastal error. First was night effect. Coastal error. Okay, so usually the density over the sea will be lower than the density over the land. Okay, density of air over the sea will be lower than the density of air over the land. Now let's say this is the coast, this is sea, this is land. Now density here is less compared to here. Okay. Now, if there is a station here, what happens when a radio wave moves from one density to another density?
Bends towards
The bend.
It diffracts.
It bends.
Refraction. What is diffraction?
diffraction is the splitting of the
It refracts.
Okay. So now the NDB signal is traveling from here. Let's say your aircraft is here. Okay, you're flying. Now that NDB is traveling, the wave will bend like this over the coast. Now, as per you, what? The station is here. But what is the reality? The station is here. This will be another error of coastline. It's not at night or day, it's all the time. We are out of night effect now. For a coastline, whenever you are flying over the water and the NDB is on land, or you are flying on land and NDB is in the ocean, which will not happen most of the time, but still, the electromagnetic waves will bend or refract whenever there is change in medium. Now, because of this change in medium, the light will, the waves which we have received by the aircraft will be bent. But that aircraft doesn't know that. Whatever it is getting, it will say, okay, I am getting the signal from here. It only knows that. So, in reality, it will give you an error than where it actually is. That is the coastal error. Got it? How to reduce coastal error? Fly as high as possible as atmospheric density will be similar at higher level. Now this air here is less dense because of the water over there. Now if you fly higher at more height, the density will almost be same over the land and sea. The density of sea will not affect that high. Okay, so if you are flying higher, your accuracy will be more because the density error will be less. Okay. Second thing is use a beacon whose signal is leaving coastline at 90-degree acute acute over the angle, more is the coastal error. Now if the beacon was here, it would have just traveled straight.
okay.
So use a beacon which is as much at less angle as possible from the coast. Now it was completely here, then the error would be this much. But if it's straight in front of you, error will be zero. So higher the angle between you and NDB and the aircraft through the coast, higher the error, lesser the angle, lower the error. Okay, so try to use fly high, try to use the NDB station which is as in front of you as possible, like as straight in front of you as possible. Use a beacon which is located near to the coastline than inland.
Okay.
Now again, closer to the coastline, reflection than staying away from the. There will be much error one in the NTP which is inland compared to the one which is at coast. You see the difference? Okay. And use a beacon which is transmitting at higher power as the bending will be less and so the error. Higher power will always be the best option. Whichever NDB is transmitting at higher power, use that. So if you want to avoid coastal error, fly high, try to choose the NDB which is straight in front of you and which is more close to the coast with higher power. Okay, transmission power. Clear with the coastal error?
Yes.
Next, third one, quadrantal error. Quadrantal error means whenever there is a, if this is your aircraft, because of the metal surfaces of the aircraft, radio is an electromagnetic wave and the aircraft is a metal surface. So whenever the signals are coming from quadrantal angles, it has the tendency to hit and bounce back and give you error reading by the time this antenna gets some information. So try to get fly to NDB which is not in these quadrantal angles. Like if you're flying on a heading 000, don't choose an NDB of 045 or 135 or 225 or 335.
Okay, got it.
Okay, because of the quadrantal error. So quadrantal error, electromagnetic field and metallic surfaces of aircraft cause radio signal to undergo a direction change before it reaches the loop aerial. This error is called quadrantal error. The error is maximum when signal is approaching the aircraft quadrantal or in intercardinal heading. Okay, whenever the signals are coming from those headings to your aircraft, your error will be maximum. Okay, so for this, aircraft is provided with correction card. Correction card, like we spoke about compass swing, they'll give you a correction card when they do the swing. Similarly, for these angles, they'll give you a correction card. If you're getting a signal from this direction, then this much is the correction you need to add will be written in the card. Okay, so then based on that you can just subtract or add that error and you'll get your accurate relative bearing. That is how you correct the error for quadrantial error. Clear, everyone?
Yes.
It is 315. Okay. Next is interference error. What is DOC? DOC.
Designated operational coverage.
Interference error is nothing but whenever an aircraft is flying and there are multiple NTB stations,
Okay.
obviously it will get interference from different stations. Okay, the all the waves will be mixing. So that is the interference. Interference of other NTB station waves with the one you are tuned to will be your interference error. That obviously makes sense, right? The error caused due to, okay, to prevent this, they have made a protected ranges or protected zones. They'll say that whenever you are in this, you first of all they'll try to place the NDB stations so that you won't get this error. And the other thing is they try to keep the frequency ranges of one next to each other at completely far away left. Like what is the operating range? 190 kilohertz to 450 kilohertz, right? So if there is one is operating at 200 kilohertz, they try to put the other one on other end of 400 kilohertz, something like that. They'll put put it in a protected range kind of things. This is how they'll try to remove the interference error. But much higher you fly, much easier for you to get other interference by the other NDBs, right? Because what happens, every NDB station has a cone of silence above them, but as we go higher and higher, that cone of silence increases, but the range also goes beyond. So you might end up getting in touch with the other NDB station. That's why you have to make sure, tune it, and first make sure identify the Morse code that you are tuned it into the correct one. Okay, if you are sure you are tuned it into the correct one. If we are too far away from that and there is one more station nearby, you might have a interference from the other station. So that's why they are protected in these types. Okay, clear with the interference error? Next is mountain effect. So whenever there are mountains or hills in the areas wherever you are flying, if there is an NDB station and there is a mountain and you are flying somewhere, you'll get one. It will be emitting in all the directions. You'll get one direct for sure, but the one hitting the mountain might reflect back and come to you. So whenever there is a mountain ranges or hills or something, there will be a direct wave as well as a reflected wave coming to your aircraft. Now your aircraft will get confused. It will be getting two readings, so it will keep fluctuating them. That will be the mountain effect. Okay. Especially in a low flying aircraft, this will be much. Like if we are flying low, close to the mountain, error will be higher. If you're flying higher, then error will be less. Next is static interferences and precipitation. About these errors, if I ask you what all the errors NDBs, you know, what all the errors NDB is subjected to, you should be able to list all of them for me. Okay, if I ask what all errors NDB is subjected to, you should tell me what all are there. First one was night effect, coastal error, quadrantial error, interference error, mountain effect, static interference and precipitation, and there are two more. You'll have to name all the 8 for me. Okay. So this static interference and precipitation is mainly because of the weather. If there are storms, if there are lightning, thunderstorms, cyclones, all those things, hail, snow will affect the receiving signal radios, because radios will travel through all that. If there is lightning happening, won't lightning affect the electromagnetic waves? It will, because lightning is again electricity, right? All those will affect the NDB waves and will give you error reading. If you're flying in such weathers, your NDBs will not be accurate. Okay, and there will also be, if there is rain. Now if it is raining, is the medium changing? Density will be changing. It is not only traveling through air, but it is also traveling through water drops. Water drops medium density is different than air density, so it will give you wrong reading again. Okay, and even the range may make a range will reduce. Okay, these causes greatest inaccuracy in ADF bearings. The weather and precipitation error will be the greatest, and you can't even do anything about it. You can't control weather unless you plan to fly out of weather and switch to a station which is not in the weather. Next is lack of failure warning systems. Lack of failure warning systems. So if ADB fails, there is no way you will get to know that it has failed or it is giving you error reading. Okay, it will like if autopilot fails, the your warning system will tell you autopilot has failed. All those things. But if ADS fails or it is giving you error reading, you will never get to know. Whether if your receiver fails or if the transmitter fails, anything fails, you'll not get to know. So that is another error or the disadvantage of this ADF. Okay, and the last one is bank angle. What is bank angle? Yeah, when you try to turn, your one wing will go up, other will go down. That is banking, right? The turning. The angle of bank induces EMFs into the horizontal elements of the loop aerial, resulting in a bearing error. This, see what the loop aerial we discussed. If it is vertical to the wave, then it will, based on point A and point B, whatever is the phase difference, it will give you the reading. Now if you bank your aircraft, it's like moving that aerial. Now will it get error? No, it should get error now, because you are not keeping the aerial perpendicular to the wave. Now you are tilting it. See, if it was just straight like this and the wave is traveling, you got a phase difference. Right? Now the same wave is traveling, but you bent your area because you are banking. The aircraft is banking like this. Then you'll get a wrong reading. Okay, so there is banking angle error also. Now you understood all the errors of ADF. Any questions or any doubts in any of these? No? You have to list all 8 and you have to individually tell me what each effect means or how to correct them if there are any corrections that can be done. Got it? Let me check one second.